Okay, so this class is Deform, Deformable Body Mechanics. Most places, almost all places call it Mechanics of Materials. So if you see that when you transfer somewhere, that's what this class is. The U of Minnesota calls it Deform, so we call it Deform. But so most of the textbooks too are Mechanics of Materials. So I'm going to go through D2L. I mean, I recognize just about everybody here, so I think you probably all are familiar with D2L and the format of my D2L site and stuff, but I'm going to go through it. So to get to D2L, which is important because all the materials that I get to you in this class are going to come from D2L. Go to the main Normandale webpage, and then there's a link up here. And you need a star ID and a password to get in. And so you'll have a list of all your classes. This is Deform. And the first thing you'll see is the announcements on the main page. And anytime I update anything, or, well, I'm not going to, I don't put announcements in if I update the grades. I think you can set it up to give you notifications when there are grade changes. But anything else, if I update solutions to problems or homework problems, or to give you your assignment for each class period, it'll say something in the announcement. So if you just like every morning go and glance at that, it'll tell you whether there's something new you need to work on or whatever. I'd say just get in the habit of checking it once a day or whatever. And then all the materials themselves are in content. And there are a few things in here. So first of all, I'm 90% of the people in here I've had classes with before, but oh, well, actually, some of you haven't ever seen this because I broke my finger. Well, I can write again on my, so the way I'm going to do all my lectures on this tablet. And so instead of seeing me right on the whiteboard, you'll see my cursor right up there while I talk. And I do that so that I can record a video as I go, and I can record the PDF. So after every class, there'll be a video that I can upload to YouTube. So if you missed the class or you want to see part of the lecture again or something, you can watch the video on YouTube, and there'll be a PDF of everything that I wrote. So it's just really nice for, you know, mostly if you miss classes, but it's just nice to be able to go back, or if you miss something in your notes, you can go back and correct it or whatever. The ones that I have here right now are the lecture notes from a year ago. So if I just go to like some random day, it just, everything that I write up there while I talk is up there. So that's the old lecture notes if you have time and you want to read ahead or something ever. I don't think there's any need to do that, but it's there if you want to. And then the assignments and the solutions to maybe half of the problems or something are here. So the assigned problems, there's probably somewhere between 100 and 150 problems total. And this class is kind of about making sense out of those problems, you know. I'm going to correct, well, not correct, but change some of these. So you could print these all out now if you want, but some of them will be changed. But I'll put something in the announcements when I change them so you know to reprint them or whatever. And then the solutions are just my handwritten solutions. And then there's also course information. In this class, one thing that is going to be really important is the math for this class is all vector and matrix calculations. And you're not going to want to do those by hand. And even with a good graphing calculator, you're probably going to want some shortcuts for multiplying common kinds of matrices and setting up, like, for example, one of the matrices that we're going to use the most often is a 6x6 matrix. But it only depends on two variable parameters. So if you know these two parameters, you can populate all these 36 values. Well, you don't want to have to go in every time you use this matrix and calculate the values of each one of these things and write them in a 6x6 matrix. And so this programs thing tells you, well, this is just for a TI-89 calculator, but it tells you the code for the programs that you need to make some of these operations that we're going to do all the time really quick and easy. You're going to want to get those in your calculator. It just would be a huge pain to do this stuff without it. I mean, you could do it, but just everything would take whatever, 30% longer or whatever. You don't have to do it on a TI-83 or 84 or 86 isn't too different from this, and I can help you with that. An Inspire is a little more different, but we can, come talk to me and we can get it figured out, whatever kind of calculator you have. But if you have a TI-89, you're in luck, because all you have to do is enter this stuff in. For the other kinds, you just need to come talk to me in office hours and we'll get it together. We're not going to need it right away, but it's going to be fairly soon, It's a slightly different set of programs, I think, that I give you for dynamics. There are probably some that are the same. I think there's some that like the rotation matrix is probably, I think there is a list of programs for dynamics, but it's different programs. Once a student came in with a calculator they bought at like Pan America or something, and they're like, can you help me enter these programs? And so I went into the programs and all my programs were already in there. Like, it was kind of cool. Like, it was someone who'd taken the class, and then I was like, wait a second, why'd they sell this calculator with all my valuable programs on it? The vector review. So the first assignment is going to be just a review of vector stuff. A lot of you are also taking dynamics, and maybe some of you who aren't taking dynamics are also taking statics. And this same vector review is going to be the first assignment for both of those two classes. So you can just pick, if you're in more than one of my classes, just pick one of the classes, do the vector review in that. You don't have to write a note to me or anything. I'll remember, but you only have to do that stuff once. So the vector review here, I think this is just the sort of body of, kind of like the textbook entry. And then there's some problems and solutions for it. But the main thing I want to talk about today is the syllabus. That's also in course information. Okay, so this is Deform. 3 credits, so we spend 3 hours a week in class. And what that means for the expected time commitment of this class is that outside of class, you should be expecting to do 6 to 9 hours of work. I think 6 would probably be fine for almost anybody, but so think about that. I mean, basically an hour a day, okay? And I think if you stay on top of material and do an hour a day of work outside of class, you'll you'll do well in the class. It won't be that stressful, and it'll be a good experience, and you'll leave here very ready for the stuff that's coming up next. My name is Guy O'Lakin. Just call me Guyo, please. There's my email and my office phone number. Email is the best way to get a hold of me. My office is right across the hall over here, 2302. That's also the last 4 digits of my cell phone number, by coincidence. So that means that if you tried 1,000 numbers, you could, at some point, you would get my correct phone number. I don't know if it's really worth it. You could just ask me and I'll give it to you. Class time. Office hours are a little all over the place this semester, but they're all in the tutoring center. And the benefit of doing them in the tutoring center is there are tables where you can work, and hopefully there'll be other students from your classes there. So you can kind of work on problems together there. And then when you have questions, you get stuck on something, you can come ask me about it. And I really think if you find an hour or 2 a week where you can treat that as just sort of like a study hall, you're going to come to office hours and work on stuff, just do it at the same time every week, you'll be impressed by how much it helps. It seems to always work well when people do that. I also, if you can't make those, I'm always happy to make arrangements outside of those times. Just send me an email and we'll set up a time to meet outside of that in my office. But it's like Monday from 2 to 3, Tuesday and Thursday from 1 to 2, Wednesday from 2 to 4. The prerequisites, statics, Calc 2, and co-requisite of differential equations. Okay, so the co-requisite of these are the prerequisites and co-requisites that they use at the U. That's why we use them here. But you could totally do this class, no question, without being co-registered in differential equations. Calc 2, you could do this class without Calc 2. There's not a lot of, the Calc 2 stuff that we'll do a review of anyways. Statics is more useful. This class is kind of statics 2 type thing. It builds on a lot of the things from statics. I've had a lot of people take this class without statics and do fine, but it makes it more work. So if you haven't taken statics and you're concerned about that, come talk to me and we'll figure it out. Let's see. Well, yeah, let's skip the course objectives and go right down to the materials that you need for this class. So there are sort of 2 odd things about this class compared to most engineering classes that you take. One is that there's no required textbook. Everything is just going to be from the lectures. And that cuts down on the amount of material you're responsible for. But it also means that since you have a small amount of material that you're responsible for, I have more of an expectation that you're going to understand that well, that you're going to take the notes and then read them and then reread them and skim them. And, what I want is just a slow, long soak of this material. And I've tried to cut it down, to as simple a message as I can for the stuff you need to know how to do. And for that to work, you need to remember what I said, If you want to get like for future reference, I don't think it would be useful at all really during the semester, largely because the mathematical way I approach this stuff is so different from the way textbooks that I've seen approach it is. But the textbook that they use at the U is this Gear and Goodnow book. or sometimes Gear and Timoshenko if it's an old enough edition. But any of these Mechanics of Materials by Gear books is a good resource, especially if you're transferring to the U. I would recommend, if you're thinking of doing that, just find an old edition on eBay or something and get a book for $30 instead of $200 or whatever. And then Sham's Outlines. I always recommend Sham's Outlines. I couldn't believe it when I discovered them. There's Sham's Outline for every science and engineering class you'll take basically from now on. They're paperback. They cost $15 or $20. They give concise little descriptions of all the topics, and then they have tons of problems with answers to all of them and solutions to some of them. So it's really nice if you're trying to refresh your memory on how to do stuff. So I would say definitely get the Sham's Outline is my recommendation. And then if you're going to transfer to the U, especially, maybe see if you can find a good deal on that Gear and Good notebook. We're going to do all the same topics that they do at the U, or that are covered in that textbook, but we're going to use a different mathematical approach, a better one. That's a undeniable reality. But I'll try to bring up the places and the ways that the way we're doing it is different from the ways that it's traditionally taught, as we get to them. The reason I do it, by the way, the reason I'm going to use sort of this matrix and vector approach instead of the way it's traditionally done is traditionally you had to be able to do these calculations by hand, like when the curriculum for this class was developed in the 50s and 60s and whatever, like you had to be able to do a lot of these calculations by hand, and you're doing matrix calculations by hand is just slow, well, now all your calculators can do these calculations, so it's sort of dumb to not take advantage of that. And I think using this vector and matrix approach is kind of recognizing what these mathematical objects really are. I think it's an important thing for understanding. And now that we have the computational strength to do it, we might as well just do it the way it is, The required stuff for this class is a graphing calculator. TI calculators are the ones I'm used to, but I know there are other good ones. And if you don't have a graphing calculator and you've been waiting to buy one, all things being equal, if you can find one that does eigenvalues and eigenvectors, I think that would be a good idea. I don't think it's super important, but it's you will basically, starting with this class, for just about every class you'll take from now on, eigenvalues and eigenvectors are going to come up in some way or another. But you can also just, so on a calculator you can do them on a test, is the main benefit over just using your phone to look them up on Wolfram Alpha or something, because you can always do that too. And then the other thing you'll need is a 3-ring binder. I would get like a 2-inch or a 3-inch one. It's going to hold all the notes for the class and all of your homework you're going to put in it. And it's the only thing I'm going to evaluate to make sure that you're doing the right amount of work with the right amount of effort, making your work legible and that kind of thing. So you're not going to turn in like daily assignments. Instead, the idea is like you turn in your daily assignments to your binder, and then twice a semester I look at your binder. The topics we're going to cover, this is a pretty exhaustive list. I don't think there's much reason to go through this like one by one, but I think I recently just did it all out in a long list like this to make it for when people transfer to places that are not in Minnesota. I think this makes it a little smoother transition to just have all of the topics that we cover right here. Mainly, like in a couple of words. What this class is an introduction to stress and strain. Stress is a local, like infinitesimal measure or a measure at a point of the loading on a material. And the strain is the measure at a point of the deformation of a material. So the stress tells you that point what are the forces it's feeling. And the strain tells you what's the stretching and shape change that it's feeling. And so we'll start by defining stress and strain. And then pretty quickly we'll get into just in actual bodies, like say long, slender beams, or say you have a plate that has loads on it like this. How do you go from that macroscopic description of what's happening to calculating the stresses and strains at the points inside the body? That's what we'll be doing this semester. The grade scale is going to be about 92, 82, 70, 60. And that's really just kind of chosen by trial and error because I've found that to be a set of cutoffs that usually do a pretty good job of dividing up the class into a reasonable number of A's, B's, C's, that kind of thing. The reason the A and B cutoffs are higher than you're used to, I really just think that mostly has to do with the fact that my exam questions are more similar to the homework questions than you're probably used to. And so people tend to score a little higher on my exams than probably in other engineering classes. I think that's sort of nice because I always felt like when I would take science and engineering classes where the class average would end up being 52 or, like the A cutoff is a 64 or something. Like, it's just not, to me, it just was never very satisfying. You feel like you're just like, it's like a competition to see how much relevant stuff you can kind of write somewhere on the paper. I never felt like that was really what engineering should be about. I mean, like, I like the idea of like, we're going to take this time to study a small number of things in detail, and I want you to leave here saying like, this is the stuff I know, I totally know it. That stuff I don't know. If I need to do that, I'll go deal with it later. I sort of don't like the idea of like, yeah, I kind of know this, I know a lot about it. Like, because when you're working for some engineering firm, if you get 64% of your calculations right, for them, they're not going to consider that an A. So yeah, I don't know. For me, like, yeah, engineering should be like, you should get it all right. That's what we're trying to, like, you should know how to do it all and get it all right. That's what we're trying to get to. The grade is broken down into mostly exams. 70% of the grade is exams. And then 15% is based on those couple of times that I collect your binders. And then 15% is based on quizzes. And I'll talk about, so now I'm going to talk about those categories one by one. The basic difference between exams and quizzes is that exams is problem solving. So it's all to get ready for exams. You just make sure you know how to do the assigned problems. The quizzes are short answer questions about what I say in the lectures. So to get ready for those, you reread your notes, skim your notes. The exams. This is my 12th year and I still like lose my voice the first day of class every single semester. So there'll be 5 exams. Since they add up to 70% and they're all worth the same amount, each one is worth 14% of your grade. And every one of the exams will be cumulative. So you need to study the stuff that we're working on, but you also need to go back and refresh your memory on the old stuff. And the way I'll give assignments, I'll help you do that. I'll make sure you're always working on some new stuff and some old stuff. Um, it says no makeup exams. In this class, that's just not really true. Just come talk to me if you have to miss an exam. Let me know beforehand and we can work something out. But please don't, let's not get into the situation where like you're taking half your exams outside of class. It works, it's much easier for me um, if everyone's taking the tests at the same time. So yeah, like maybe one test if you have something else going on, that's no problem. Two, but let's not. You got to be able to take most of the tests here. And then the way exam 5 works, it can work as sort of a mulligan if you mess up one of your first 4 exams and you score better than that exam on exam 5, then that exam 5, the final, will replace the one that was bad, and it'll also count as itself. So like if you totally bomb exam 2, like you misunderstood what topics were going to be on it, and you don't know at all how to do 2 of the problems, and okay, so it's a disaster. Then at the end of the semester, you get a 90 on the final. Then that counts as a 90 for the final, and it also counts as a 90 for replacing the 60 or whatever you got on exam 2. If your final is your worst score of the semester, then it just counts as the 14% for exam 5, and all the other scores stay. So if you do badly on the final, it counts as 14%. If you do well on the final, it counts as 28%. And then here are the dates of all the exams. And the final is the Monday of finals week at 2 p.m. So you might want to, if you have a calendar out that far, you might want to just look at these dates and make sure they work. And if they don't, talk to me as soon as you know. Any questions about the exams? Okay. The next thing is the binders. And I made this mistake, I think, in Dynamics 2. It says your binders should have dividers to split it into 3 sections, and then those 3 sections are the 4 sections listed below. It's really 4, so I'll change that. But so the first section is just you should put all your class notes in there, and you have to make sure you have notes for every class. If you miss a class, it's easy to get the notes. Just print out the PDF that I put on D2L from that day, or obviously you could photocopy your friend's notes or whatever, but you can't have gaps because since we don't have a textbook in this class, this is going to be your main source for going back for information later, so it's important that you have everything in there. It's also important that it's legible. So if you have a day or multiple days where your notes are really hard to read, like you were scribbling stuff all over and crossing out big sections, then you need to rewrite your notes. Or you could just print out the PDF of my notes. That's always fine. But it needs to be legible. And then the next 2 sections, so first there's assignments and solutions. That's where you basically put your homework after you finish it. But I said that everything in this class is going to be cumulative, and that means that you need to always be working on some old stuff and refreshing your memory, working on some new stuff and refreshing your memory on some old stuff. And so the way I'm going to give assignments is after every class period, usually in the evening, I'll give a few dates of notes that you should read. One will be from that day's notes, and then there'll be usually a day from 2 weeks before and a day from 4 weeks before. So you're always like going back and refreshing your memory on that stuff. And then there'll be assignments. There'll be problems assigned from the new stuff that we're working on. And then there'll also be repeated problems. And so those are, so you'll go back and those will be actually problems that you've already fully done before, and they're already in the part of your binder for the assignments, but you're going to do them again. And I think when people first hear about that, they tend not to like that idea. But I think you'll find that redoing problems after you let a little time go by is just a really nice way to solidify those concepts. I think you'll find that you remember it a lot better, you understand it a lot better. It's also sort of a way to test yourself, like how well do I know this stuff? Do I still remember how to do it? You know, try to do it without looking back at your notes. And I think the fact is that most of the people who do great in my classes and probably most classes are actually doing that anyways, you know, so I mean, I think it's always a good idea in every class, if you can find the time, do a problem once, let a little time go by and do it again. And that's what we're going to do anyways in this class. As it says in there, like you could just copy everything, like I wouldn't know from what you did before, but it would just end up being a waste of time. You know, you get the points, the binder points for it, but you wouldn't get any of the benefit out of it. And the only reason I have you redo problems is because I think there's a lot of benefit to it. So I would definitely recommend that you don't do that. Okay, and then when you get the exams handed back, 3-hole punch those and put them in the back section. It's just nice to have that there when you want it. And here are the 2 dates that you'll turn in your binders: Wednesday, February 13th and Friday, April 17th. And each one of those times will be worth 7.5% of your grade. I mean, for the most part, I'd say 3/4 of the class gets perfect scores on the binder evaluations. I mean, it just means that you're spending the right amount of time on stuff. You're doing the work with appropriate thoroughness. You know, when you don't know how to do a problem, you're getting help on it. So everybody can get a perfect score on that. Any questions about the binders? And then the quizzes. So like I said, the exams are all problems, you know, problem solving, doing calculations. The quizzes are just making sure that you're reading back over the notes and reminding yourself what we're doing. So those are short answer questions on what I consider to be the more important topics that I bring up, or sort of like the key points, you know. As we get closer to the first quiz, I'll give a couple examples of the kind of questions that I would ask. Those just take like 10 minutes, last 10 minutes of class, once every 2 weeks. So every 6th class or something. Dropped your pen. And yeah, it's just sort of a question of whether you remember what I said or not, you know. And there's the schedule. Also, the lowest quiz score gets dropped. So your quiz score is 15% of your grade, and I guess that's divided up among 5 quizzes. So each one's worth 3%. And then I just have this on here. I really never have problems with this. But please do your part to make this a nice environment for people. Don't talk about outside of class topics while I'm lecturing. I have this in here because one semester a few years ago, I had a student who made this class very unpleasant for me with like sort of outbursts and jokes and stuff just the whole semester. And so if I can nudge you towards not doing that, this is the way I thought of to do it. But like I said, it won't be a problem. And if you don't understand, I don't want this class to feel like a police state, you know. I just don't want you like talking about nonsense while I'm trying to lecture, you know. And we'll have a lot of times where I'll ask questions, and you know, we'll have some times where I have you split off into pairs and work on problems and stuff. So, okay, and then don't cheat. I'd say that's probably good advice for most classes. Anybody have any questions about, yes, about the cheating?
In dynamics, I was wondering, would you still have all those equations on the back?
Yes, I'll give you all the equations you need. And in this class, especially, a lot of the equations will be like programmed in your calculator, hopefully. But yes, I'll always give you all the equations. Any other questions? Yes. So I guess that's it for today. I will give you an assignment related to that vector review. So look for that. You know, it'll be up sometime tonight. Try to get to it as soon as you can. And get your binders together. And if you're taking other classes with me, you should have a separate one for each class. Okay, thanks. See you Wednesday.
Yeah,
Hi.
I did say it for dynamics as well.
Okay.
Just didn't finish the slide.
Oh.
I missed it this morning because I just let me know if someone uses stuff in.
Oh, okay.
I did not even register for more than one class.
Wow. Wow, amazing. I did not know that. Okay. Well, what I said here is exactly like what I said in dynamics, except the dates are different. So yeah, just look on the D2L on the syllabus. All right, see ya. Hi. Oh, I didn't toss them. Let's go look and see. I can't remember where I was when I graded them. They might be at my house, but let's go look. Hi. How are you? Good. Okay. Okay. That's good. Statics, dynamics, and deform?
Yeah.
Okay. Yeah. You have a pen with you? Let's see. Oh, I got one. Yeah. Mechanics of materials.
Mechanics and oh, it's not the strength of material.
Oh, that probably is it too. Yes.
Because I took this class like out of the States.
Okay, yeah.
I'm not just gonna work here or not.
Okay.
So
Yeah, do you know yet what university you're gonna transfer to? Here?
Mankato.
Mankato?
Yeah.
Yeah, you should contact them and just see if
I mean, like from now,
Yeah.
I may stop. Like this is my last, gonna be my last semester.
Yeah.
I'm gonna stop for a little bit because of trouble.
Okay, yeah.
Like home.
Okay.
And I don't know like how that's gonna work here
Mhm.
if I want to transfer. Or you
Yeah.
can look at the syllabus or
When you transfer to Mankato or to
I mean
here?
to you here.
Well, to us, I guess I would say there's not really any need for you to transfer. Maybe to show that you have the prerequisites, I guess, is the only reason you would transfer stuff here. I think
Through you, like
Yeah, you just end up. What matters is that when you transfer this stuff to Mankato,
okay.
so
I
you
mean, like for me also like in order to get my degree.
Oh, you want to get a
diploma.
2-year degree from
Yeah,
here?
my
Okay.
diploma. That's
So, okay, that's a good question then. Do you know where the best advice I could say?
This is me everything if you
Yeah.
want to take a look at it.
I would say just go to the go to the registrar's office downstairs and ask them what you have to do to transfer that.
To here.
Yeah, but I would guess that strength of materials will transfer as this class.
So like, say like I went to them, I like talk to them, so they gonna like talk to you or like ask you to go. I mean, ask you to go through the like my syllabus or whatever.
They would only ask me, I think, in the cases where they weren't sure how it would transfer. So like they might talk to me about strength of materials, and then that's when I would like look at the syllabus to make sure that it's the same class. But like, let's see what else. And then, you know, math 2, is that calculus 2?
I already took one of the classes here.
Oh, here you took them. Oh, okay. Oh, and that's no problem.
Yeah.
So maybe this is the only one that really matters.
Because like I kind of like when you said like strength of material, or like you see it's strength of materials.
Yeah.
Yeah.
Do you have your syllabus with you?
I do.
Okay. Yeah. Let me look at that.
I'll take it.
Do you have a class after this?
No. I wonder if theory of structures is statics.
Oh, there's another page.
Oh, or I wonder if engineering materials is statics.